Objectives for today are to factor binomials, trinomials, and polynomials. To find and use greatest common factors among constants, variables, and expressions. For example, we have a squared plus a. We want to find the greatest term that can come out of both a squared and a. The coefficients are 1 on each, so you don't have to worry about them. Coefficients are numbers to the left of the variables. They're 1 in each case. No need to worry about them. You can take an a out of a here, but you can't take an a squared out of a. You cannot divide everything by this a squared. It'll divide into itself, but it's too big for a. The most you can take out will be a from each one. So when I do that, I have to work backwards. What would I multiply a by to get a squared? A. And what would I multiply a by to get itself? 1. Final answer is a times the quantity a plus 1. In this case, we have b to the third plus b to the second. You can take a b out of both items, but b is not the highest one. You can take b squared out of both of them. B squared will divide into itself evenly, and you can divide b squared into b to the third without going over. You cannot take out b to the third because it's higher than b to the second. If I divide out b to the second, I'm left with this, b to the third divided by b to the second plus b to the second over b to the second. But you must simplify that. B to the third over b to the second leaves you with just b, and b squared over itself is 1. The final answer is b squared times the quantity b plus 1. This one is c to the third plus c. What's the highest thing I can take out of both of them without going over when I go back to divide? C. So I'm going to divide c into both of those. C to the third over c plus c over c. C to the third over c is c to the second power. C over itself is simply 1. C times the quantity c squared plus 1 is the final answer. If you had two numbers such as 10 and 4, and you wanted to find the greatest common factor, the highest number you can take out of both of them is what? 2. You can't take a 4 out of 10. This is where we get to the point to where if you struggled with stuff before, then it's not going to be well at this point. You need to know how to factor certain things, especially just integers. The highest number that comes out of both is 2. So if I divide 10 by 2 and 4 by 2, then I end up with 5 plus 2. And this is the same thing we're doing except with variables. You couldn't take a 10 out of 4, that's why we don't use 10. You can't take a higher number out of a smaller one without getting a decimal. For the practice problem, it is true that you can take an a out of both items, but when you do that, you're still left with a to the third plus a squared, which means you did not factor completely. What is the highest power of a that you can take out of both of them? A to the third power is the highest one you can take out without going over. So divide a to the fourth by a to the third and a to the third by itself. Your final answer should be a to the third times the quantity of a plus 1. For this bonus problem, anytime you divide two variables that are the same letter, you subtract the exponents. The answer is a to the fourth. In this problem, you have 4a to the third plus 6a to the second. In this case, you have numbers and variables mixed together. So first, concentrate on what the highest number is, the highest constant you could take out of 4 and 6. 2. 2 is the highest number that comes out of 4 and 6. Now, concentrate on the powers. What is the highest power of a that can come out of both of them? A squared. The highest power of a squared, will come out of both of them. Once you do that, you have to go back and divide to see essentially what you'll be multiplying 2a squared by to get back to what you had up here. So 4a to the third divided by 2a squared, and then 6a squared divided by 2a squared. So inside the parentheses, 4 divided by 2 is 2, and a to the third over a squared is a. And then 6a squared over 2a squared, 6 divided by 2 is 3, and a squared over a squared is just 1. Do not write 3 times 1 in there. If it just comes out to be 1, you just leave the 3 by itself. Don't put a times 1 beside it. So your final answer is 2a squared times the quantity of 2a plus 3. Another example, a or 8, a to the fifth minus 12a to the third. Concentrate on the numbers only. 8 and 12, what is the highest number that comes out of both? 4. And then concentrate on the a's. What's the highest power of a that will come out? 3, so a to the third. Now go back and divide to figure out what goes inside the parentheses. 8a to the fifth divided by 4a to the third, and then minus 12a to the third over 4a to the third. Simplify inside the parentheses. 8 divided by 4 is 2, and then a to the fifth over a to the third is a to the second. 12 divided by 4 is 3, and then a to the third over a to the third is 1. Your final answer is 4a to the third times the quantity 2a squared minus 3. This practice problem is 16a to the fourth plus 10a to the second. For the practice problem, the highest number you can take out of 16 and 10 will be 2, and the highest power of a that comes out will be a squared. Go back and divide 16a to the fourth over 2a squared, and then 10a squared divided by 2a squared. Simplify what's inside of the parentheses to get 8a squared plus 5. In this problem we have 3a to the third minus 6a squared plus 12a. Concentrate on the numbers only first. 3, 6, and 12. The highest number you can take out of all three of those will be 3. And then a to the third, a squared, and a. The highest power of a that you can take out of all three of those will be a. And now go back and divide everything by 3a. Simplify inside. 3 over 3 is 1, and a to the third over a is a squared. 6 over 3 is 2. A to the second over a is a. And then 12 over 3 is 4, and a over a is simply 1. Final answer is 3 times the quantity, a squared minus 2a plus 4.